Growing up, I earned a reputation as the guy who was good with computers. I'd update my family's PC and keep it virus-free. I'd help my friends burn CDs and download MP3s. I'd use my supposedly arcane knowledge to install software for my teachers and edit the videos I made with friends at school. Now, as an adult, I sort of assumed we'd have figured all this stuff out by now. I thought I'd be obsolete. But the more things change, the more they stay the same. I still help my in-laws with their TV and make sure my mom's computer is always backed up, with Dropbox, of course. Whenever my best friend's phone stops working, you can probably guess who she calls. Nothing feels as seamless or as easy as it should be, especially when it comes to the way we use technology for work. But I don't think it's our fault. If our apps and devices are so powerful, why aren't they better at understanding, anticipating even, the things we want to do in whatever way makes the most sense to us? I'm your host, Matthew Braga, and today I'll be talking to Babak Hodjat, the Chief Technology Officer for AI Research at Cognizant, an IT services and consulting firm. Babak's team helps other companies integrate AI tools into their workflows. It's work he's been doing, if you can believe it, for nearly 4 decades. And if there's one thread that runs through Babak's career, it's how to make working with technology feel as natural or effortless as working with a colleague, or the good with computers person in your life. Easier said than done, right? But with recent advances in AI, we might actually have a shot. Oh, and trust me on this, even if you don't know Babak, you're almost certainly familiar with his work. That's coming up next on this episode of Working Smarter. Babak, thank you so much for joining us.
Thank you for having me.
So maybe to start off, you can tell me, who are you and what do you do?
I am the CTO for AI for Cognizant, which means I lead an AI R&D team here in downtown San Francisco. My background is in AI. I have a PhD in AI. I got into AI in the late 80s, and I started several companies. One of them led to Siri, so I was the main inventor of the natural language technology behind Siri. I was not part of Siri officially, but my team started Siri. And then I started Sentient Technologies, where we worked on distributed AI, and then we joined forces with Cognizant. In some roundabout way, I feel like I'm back to natural language again. But yeah.
Well, and we're going to dig deeper into a bunch of that stuff. But I think the first thing that I wanted to ask you, and I think it's a good place to start, is, as you say, you've been described as the co-creator and the co-inventor of the technology that eventually became Siri. And I was wondering if you could explain the story behind that.
Yeah, I was working on agent-based AI in the late 90s, and I was looking for an application for it, because I felt like it was very powerful. A friend misunderstood what I was doing when I said agent-based and thought agents are these representatives of humans with whom you can speak natural language and would understand and then go do some stuff on your behalf. And when I told him that's not what I meant and natural language is very, very hard, he challenged me. He said, well, if you think your AI is powerful, why don't you apply multi-agent systems to natural language? And I took that challenge on, I worked on it, and I came up with an approach that was very different than how people did natural language. They used grammar-based approaches and language-based approaches before. And this one is basically starting from the ontology of the domain that you're talking about. So it's very, very different. So that led to Dejima, which was my first startup in 97, 98. And as Dejima, we worked on a project that DARPA was running called the Kalo project, and it was being done through SRI. And then the company Siri was born out of that Kalo project at SRI. And our VP of engineering and architects and a lot of the folks that were at Dejima actually ended up working on Siri, and they did adopt the core natural language technique and technology that we had come up with.
I'm curious, your friend had one idea of agents and what agents meant. What were you thinking about when you thought of the word agents? What did that mean in your context?
Yes. So AI started off being this quest for building an all-intelligent system. And in the late 80s and 90s, AI scientists realized that that's too big a problem to tackle. So what if we actually simplify the problem? And so in a simplified world, then use an AI system to operate in that world rather than the outside world with all its complexity. And that is what they refer to as an agent. And then a multi-agent system kind of came out of the fact that, okay, if I have an agent out there, let's say on the World Wide Web, which, that was the time when people were thinking about the web and browsing stuff and searching for stuff on it. If my agent runs into somebody else's agent, how are they going to talk? How are they communicating? Whether they should be collaborative or competing. And so this multi-agent concept started there. What I was working on was, okay, so let's imagine you have many kind of idiot savant agents that have very, very simplistic worlds they operate in. Can you get them to solve larger problems just by virtue of the emergent behavior that comes out of them trying to survive an environment? So while it was still called agents, in some ways it was more about, simplifying the AI. What my friend misunderstood was, he was actually at a bar, and this lady, this old mama-san at the bar in Japan, was trying to get the tennis game, and she tried with the remote and everything and couldn't get it, and so she turned to her son and said, "Get me the tennis." And so the complexity of get me the tennis, what channel is it on, how do you operate the remote, how do you get the TV onto the tennis match that she was interested in, all of that was something that the agent did on behalf of the woman. The woman is just like the mama-san is just expressing their intent. So yeah, it's worlds apart. I can tell you natural language is hard. It's still hard.
Everything you're describing, this idea of splitting the problem into all these different agents, they handle different tasks, they do different things, and you have to figure out how to wrangle them all and make them talk to one another. Does it feel like we have come full circle again into this present moment, given the things that people are building? Because it seems like people are trying to solve a similar problem now, building tools that can interact with all of your different apps, your different devices, different contexts, different data sources.
We have come full circle. But the reasons why we're now operating agents is very, very different. It's actually completely the opposite. So back then, it was because our AI wasn't powerful enough, so we had to simplify the environment they operated in. That was the agent. Today, our AI systems are powerful, in fact, so powerful that we have to contain them. They're so robust. This agent can take any different persona. You can tell it that it's an expert in field 1 or an expert in field 2 or an ordinary user or a hacker or whatever. And depending on what persona you give it, it'll have a different behavior. For us to be able to utilize this AI, we have to actually limit its operation to the workflow that we're interested in. And that's brought us full circle back to, okay, we have to think about these large language models as agents when we plug them into a workflow. So yeah, different reasons, but the end result is the same. And in fact, I think we are moving towards a multi-agent world because now as we set up these workflows, we want different agents responsible and being experts in different parts of the workflow to work together. But the world is much simpler. Like we can program these agents using natural language. We can actually tell them what we expect from them. They can talk to each other in natural language. And that is worlds apart from the multi-agent systems that we had back then. We had to define inter-agent communication languages that were very elaborate and were hiding certain information and revealing certain other information and so forth. And you don't need to do that.
Well, and to your point, I mean, we've obviously gotten a lot better at doing this kind of thing today. But I feel like there's still challenges with making our technology, our machines, our devices, our apps understand what we want them to do. Like it still seems like there's a bit of a ways to go. And so I'm wondering, what makes it so hard to get this right? Why is it so hard for our machines to be able to understand the intent behind what we want them to do in a way that's natural to us, rather than us having to, contort ourselves into what our machines expect from us?
There's several reasons. One being that currently the state of the art is a very question answering kind of state of the art. And the context that these large language models have is limited to how you express yourself in natural language. Natural language by nature is ambiguous and could be terse and takes a lot for granted as far as the context is concerned. And these large language models have nothing to go by other than the exact words that you tell them. You just nodded. That nod tells me that you kind of agree with me or you appreciate the point that I'm making. They don't see that. So, of course, we're moving beyond that. We're trying to make them multimodal. We're trying to make them more reactive to other cues. So that will help. But that's one limitation that we have. The other limitation that we have is the fact that these systems are pre-trained. The PT and GPT is pre-trained, which means that their world model is fixed. And because they're very, very robust, they can be pushed to view the input and behave differently depending on what we ask them and how we set them up. But unlike humans or other higher order intelligence animals, they don't learn as they go. They're not embodied. And that embodiment really helps us situate ourselves in a context and understand what's going on. In spite of all of this, I must still say that as humans, we misunderstand each other all the time. I mean, that's just a byproduct of how our languages have evolved. So you can't blame machines for misunderstanding. We're no longer programming them in a non-ambiguous, programming language. We're literally using the same language, the same operating system we use ourselves in our community. So some level of misunderstanding is just, it's par for the course.
So earlier you mentioned the Kalo project that you and some colleagues were working on that helped to lay the groundwork for Siri. And I was looking back at some articles that were written around the time about some of that work, specifically about the perceptive assistant that learns, or PAL, that your company was working on for DARPA. At the time, in these articles, PAL was described as an office assistant, something that could set up meetings, answer emails. It's a lot of the same stuff that people seem to be talking about using AI and specifically LLMs for today. And I'm wondering what you make of that. I mean, is that notable that the path forward almost 2 decades ago was sort of similar to what people are identifying now? Is it prescient or is it, what do you make of that?
Yeah, I think it's the case that is still a hard problem and has not been solved. I think it was year 2 or year 3 of the Kalo project when we actually set up a system where you would pick up the phone and you would tell Kalo basically that you wanted to set up a meeting with, these people. And then Kalo would actually contact them. It would look up your contact book. If there was a phone number, it would call them. If it was an email, send them an email or whatever, and coordinate and find the time. If it had access to your calendar, then it would use that. It would actually find the time, block the calendars, invite everyone. And then on the day and time when the meeting was going to happen, all you had to do is walk into the conference room and it would actually dial everybody out. And when I describe that, even today, we don't have a system that does that easily for us, even right now. So yeah, I think it's prescient only because it's a problem we still have. The original Dejima, people wanted to program their VCR. I don't know if you remember back then, but that was a thing. Like, I wish there was an AI system that could program my VCR. So that was the original use case that we worked on, was how do you program your VCR using AI? You still don't quite have that. Hopefully with generative AI systems and interfaces, we will finally get it. But it's been like 20, 30 years now.
Well, and you said, I mean, that's still as difficult a problem today as it was then. Setting up meetings, answering emails, like writing reports, like why is that still so difficult, I guess, to pull off today?
I mean, we have the components. I can tell you, we set that up as part of the Kalo project. So it was actually working. The question of why there is no product that actually does that, I think that comes down to, the viability of the business case for it more so than the actual technology. I think it is possible to do it. I mean, how often do you use Siri? We talk about Siri. I personally don't use it that often. Why don't I? I mean, I had this traumatic experience. The first time I actually set up the precursor to Siri, there's this microphone set up in front of a TV set and a DVD and a satellite, 500 channels, and it turn on the lights and whatever. It has all this functionality. And I had one of our advisors, former chairman of Borland, was there. And I just sat him there and I gave him the mic. I'm like, you can say anything, go ahead. And he just looked at the mic and he said nothing. And it was this awkward minute or two of him not saying anything. And I'm saying, why don't you just say something? And he's like, I'm thinking. And he finally turns to me and says, well, I don't typically talk to my TV set, so I don't know what to say. So there's that side of it as well. Like, even if we put that functionality in a system, will you talk to it? Would you anthropomorphize your system to a point where you would trust it to be able to do what it can do and talk to it in natural language? And like, how often do we talk to our Alexa system in the corner of that? It's this cylinder sitting in the corner of a house, and I'm sure it does tons of things, but do we really talk to it that often? No, it's just a cylinder. I mean, we're not used to talking to a cylinder,
Well, then I wonder, where do you think AI could have the most impact on how we work and how we get stuff done today? I mean, is it organization? Is it search? Is it collaboration? Is it something else? Like, where is your mind at right now?
Today, most of, at least the folks that we see, are scratching the surface of applications and use cases. It's mainly around, I want a ChatGPT for X, or I want to be able to do a document search on my proprietary document repository, or I want to make my developers more productive. But I think we're going to move to using this agent-based concept and start augmenting and improving our business workflows using these agent systems, which means that we're actually using them for the reasoning, for their ability to make decisions kind of out in the wild and make calls to the tools that we provide to them, like the API that we might have or what have you. So I think we will move to that point. It's a leap of faith, though. If you have this technology that potentially is a knowledge worker for you, you can do all sorts of things, but how do you constrain them? How do you make sure that they operate in a responsible way? Who is responsible when they screw up? There are a lot of those types of questions that we need to answer, but on the other hand, they're so useful and they can do so much that I think they will start infiltrating into our organizations and improving all manners of decision-making and business workflows.
I'm wondering, at Cognizant, you lead this team, this R&D team that helps bring advanced AI solutions to businesses. And I'm wondering, what are some of those workflows, or maybe some of those biggest challenges that you've been helping companies address in your role so far?
We start with the KPI. So we're like, what is the KPI you care about? And let's work back from there, because we want our AI to be aligned with you as far as what it's maximizing and what it's minimizing when it comes to the KPI. So I'll give you an example. Let's say there's this retailer, and what we want to do is help the retailer make decisions with respect to its supply chain. And the decisions could be things like, which carrier should I hire for this particular delivery? Should I or should I not change to the delivery route? How many runs should they take? Blah, blah, blah. So there's a bunch of decisions we want to make. Again, primary to all of this is the KPI. What are we trying to solve for? Well, we want the shipments to be timely. We want to minimize our costs, and we want to, let's say, maximize revenue or some other top-line KPI that we care about. So now we have the whole, basically, scoping of our use case, which basically is, okay, here are the actions you can take. Here's your degrees of freedom. Here's the outcomes that you're trying to optimize for. And here's the information you have, like what carrier am I running right now, or what route is it, or what am I actually moving, and stuff like that. So then the next thing we do is we actually line up the generative AI-based agents. We give them the tools, which is, I have this predictor model that can predict this KPI or that KPI. I have this optimization that I can do that gives me some sense of what actions to take. And then the good news is these agents can talk to each other in natural language. So they're very, very robust. As things change, attributes change, new data comes in, they can account for that. And they can talk to us in natural language as well. So they can give us their best estimation as to what to do for a specific route. And they can also answer questions about it. Like, oh, what if this carrier is not available? Or, you know what, I didn't have a very good experience with this other carrier. Do you have any other suggestions there? So that's just one use case, but you can use it for procurement, for manufacturing, for your support desk, you name it. So for some of these, you can actually defer to the generative AI's world model as well, which is something you would do with a knowledge worker.
So in the examples that you just gave, we're talking about KPIs, we're talking about sort of the business objectives that are possible. I'm wondering, what about on the level of, an individual knowledge worker? What does success look like for a deployment for employees? Like, is it time saved? Is it, reducing the amount of toil that you spend on a particular task? Is it increasing productivity? What does success look like in that context?
So a human knowledge worker is faced with decisions they make all the time. A lot of those decisions are informed by their expertise and their experience, but that could cut both ways. So they might actually miss on certain aspects of a nuanced decision point. And so actually having a generative AI-based knowledge worker on their side that can help them and expand their horizon of what they look at before they make a decision and allow them to consider alternatives is actually helpful. It's useful. So it's not just the efficiency, it's the quality of the decisions that you're impacting as well.
And I'm curious as well, if an agent like this or a system like this can save us time, can make us more productive, I'm wondering what that frees us up to do more of instead.
That's a great question. I can tell you, I don't know the answer to that, but every time a technology as disruptive and general purpose as this has come around that has made us more productive, it has made us busier. I guess in some ways, we would want to look forward to a world in which we have less things to do. but I don't think that's going to happen. I actually think that by virtue of being more productive, we are going to have more things to do. We're always going to be a step ahead of this. I think generative AI is like a calculator. All of us should be using it, and all of us will be using it. And all of us will be thinking of ways to use it to make the world a better place. Hopefully, most of us. And yeah, I think that's our role, staying ahead and mastering this technology for the good of humanity is what we're always going to be doing.
Working Smarter is brought to you by Dropbox. We build AI-powered tools that help knowledge workers get things done no matter how or where they work. Tools like Dropbox Dash, an AI-powered universal search tool designed for all your cloud content, no matter what you're working on or where it's stored. Figma, OneDrive, Salesforce, Notion, your email, your desktop, your calendar. With Dash, you can search it all. Ask a question and Dash will find you the answer, whether it's hiding in an untitled doc or one of 200 open tabs. Collect and organize cloud content with Stacks, shareable smart collections that go beyond what's possible with bookmarks and folders. And like any good assistant, Dash even knows your schedule, from the files you need to start your day to the meetings you have after lunch. Because the less time you spend on work about work, the more time you have for the work itself, the work that really matters. To learn more about Dropbox Dash and try Dash for free, visit dash.ai and discover a more enlightened way of working.
Whether it's keeping up with the rapid advancement of artificial intelligence or making sense of tech policy and regulation, you need to understand the business behind the innovation in your life. That's why Marketplace Tech is essential listening. Each weekday, we'll help you navigate the latest developments. Listen to Marketplace Tech wherever you get your podcasts.
Where have AI agents had the biggest impact on your day-to-day life lately?
I use AI agents for a lot of things in my personal life as well as work life. It's my best coding buddy. I use them to write code. I use them to make decisions and choices when it comes to how I'm going to approach critical meetings and workshops and those sorts of things, especially if there's a client involved and I really want to know what is the best approach to talking to these folks. It's amazing how powerful these things are. I think like any other tool, you kind of, after you play around with it a little bit, you kind of get kind of a knack for how I can use it and where it kind of falls short. When you start using it, you start using it more and more and for more things. And so now it's kind of a little bit of a cheat. Like you run into a problem you have to solve and you're like, your first inclination is, can generative AI help me here or not? So yeah, definitely.
What is something that you wish AI, generative AI, an LLM, whatever it may be, what is something you wish it could do or a problem it could solve that it can't yet?
That's a tough one because these are general systems. There's a lot that they can do, but it's on a continuum. So there's certain things that they can't do very well. And so the wish is more, can they get better at this? Like, can they get better at math? Can they get better at writing code? Can they get so good, like as far as their context window is concerned, that I can give them an entire book and have them read it and then give me some tips on it or something? So it's on a continuum. There are some fundamental weaknesses that generative AI systems have. And that's more, again, a challenge for us that are working in AI to overcome. But one of them is the fact that they're not embodied, the fact that they don't learn as they go. They're very, very generalist. And that has its advantages. But on the other hand, every time intelligence has evolved in the natural world, it's been a learning system that kind of adapts and learns in its environment. So you would expect that from a machine learning system. But fundamentally, the way at its core a generative AI model is a deep learning neural network, it's very difficult to have it intrinsically be learning as it goes. You have to kind of play tricks to make it kind of mimic that. So that's one area I think is important for us in the AI world to try to solve. And I really do think that we're a few major breakthroughs away from being able to crack that nut.
Well, and we've also been talking a lot about natural language, things like talking and writing. But I also wonder whether there are other forms of interaction that are going to be increasingly important for us to consider or work in as well, especially when it comes to, I'm thinking of people who maybe have different abilities, right? Maybe those who are visually impaired, who are deaf, where the things that we're talking about as natural don't come as naturally to them.
Yeah, well, the architecture at the core of large language models is a transformer architecture. And as long as you can actually pose anything as a string of tokens, these architectures are actually quite good, surprisingly good even on visual related tasks. And the latest models that are coming out do have some multimodality. For example, Gemini actually is an inherently multimodal system. So if video is considered a string of tokens, and you can easily see it as that, then a video feed could be part of the input to a generative AI system so that you can talk, you can gesture, use sign language maybe, and the system would still understand that. Now, the main issue we have right now is that to enable that, we need very, very large models. These models, the larger they are, the slower they are, and the more expensive they are to operate, and the more expensive they are to train. On the other hand, like any other technology, initially you get the big, slow version, and then we, as humans, keep optimizing and make them faster and smaller. So that is definitely the trajectory that we're on. And so hopefully in the next few years, we will get to a point where those other modalities are viable.
So throughout this conversation, I've slipped into using the word agent because we've been talking about agents a lot. But I know that people also use other terms to describe the AI tools that are available today. You hear co-pilot, you hear assistant, you hear helper, even companion. What feels like the right frame to you?
I like the word agent. And the reason for that is because it actually forces you to think of this system as a knowledge worker versus a knowledge retrieval system. I think that distinction is very important. You don't want to rely on its learning corpus to come back to you and do stuff. It's pre-trained. That learning is outdated very quickly, and who knows what kind of biases or whatever else is in its world model. You really want to give it some tools like you would to an agent, and then give it a task, and then have it go do that task for you. So I do like the word agent. Copilot is good if we want to give people the comfort that, it's always going to be side by side with a human, but not always. Why? Like, there's a lot of tasks already that we delegate to technology to do on our behalf. Why should every use of AI be a sort of a copilot kind of usage?
Well, and you've used the phrase embody a couple times as well, this idea that, these aren't systems that are fully embodied yet. And I am wondering, what will it take to get there? What needs to happen before we can have a system that does more of what you're describing, that ability to learn, that doesn't just rely on a pre-trained corpus of information?
We need some major breakthroughs to be able to do that. Right now, we use backpropagation, which requires a lot of data, and you have to go through that data over and over and over again to nudge these neurons to do what you expect them to do. So that the training is just necessarily offline. And then post-training, we do some fine-tuning. You are really not changing the world model as much as just tuning it to prefer one over the other. And none of that is very satisfactory. There are approaches that are much more efficient. Evolutionary computation is one. There are symbolic approaches that within the world of AI people have worked on. And I think if we look at generative AI as a proof of existence, in other words, if you can scale a system the way we have and task it with a problem like language modeling the way we have, there will be emergent behavior that ranges from reasoning and some math to poetry to language to all that kind of stuff. So that proves that there is at least one path to get there. So maybe we can use elements of that, but use a completely different approach that would be more explainable, would be actually conducive to online learning and to correcting and modifying the world model of these systems as they go. And that's when that paired with much more efficient systems would get us to an embodied version. There is a proof of existence of that as well, which is the human brain. So we know that is also possible. It does start more or less from scratch and learns and absorbs, and it can change its world model with one instance. You show it one example, one counterexample, and it modifies its world model. It's very, very plastic in that sense. So why not expect that plasticity in our AI systems?
We're talking about the future right now, in a sense, and I'm wondering, what are you looking forward to in the future, both professionally, but also with some of the ongoing development in AI more generally?
In the shorter term, I'm looking for more efficient, more powerful models, for sure. I'm also looking to see people adopting this beyond the obvious. Like most of us, our first experience with generative AI was ChatGPT. So it's a chat interface and it can do certain things that have to do with language or writing code. So most of the use cases we see out there are kind of offshoots of that. But as I mentioned, there's so much more that can be done. So I'm really looking to that flourishing of use cases and the pervasive use of these systems. In the longer term, I want to see breakthroughs. In fact, in some ways, it's not a good thing that we're myopically focused on one architecture, one way of training a model, and one kind of use for these generative systems. The field of AI is much, much, much wider than that. And everyone seems to be focused on this one path that has resulted in some fascinating breakthroughs, but it's just one. And in the future, I do think that we need to start exploring. We need to be more creative so that we can overcome some of the challenges of this particular approach.
I think that's a good place to leave it. Babak, thank you so much for joining us today. It's been really nice having you here.
It's been awesome. Thank you. And really, really good questions. You kept me on my toes.
Thank you. Another thing I remember from when I was younger was the first time I tried to talk to a phone. Not on the phone, but literally, like to it. It was an old Nokia, like T9 era, that had some very basic voice recognition on board. It didn't matter how hard I tried, I could never get it to work. But we've come a long way since then. Our assistants are pretty good now. Whether I'm asking my car to change the music or talking to ChatGPT, it feels like we've got the recognition part down. As Babak says, where things get real interesting is when we go beyond the basic commands, the questions and answers, and throw reasoning and decision-making into the mix. Already, we're starting to see AI-powered tools that anticipate what you need and when you need it without you even having to ask. The kinds of tools that won't just do what we tell them, but actually understand our intent. Whether you're trying to prep for your next big meeting or just want to watch tennis at the bar. Working Smarter is brought to you by Dropbox. We make AI-powered tools that help knowledge workers get things done, no matter how or where they work. You can listen to more episodes on Apple Podcasts, YouTube Music, Spotify, or wherever you get your podcasts. And you can also find more interviews on our website, workingsmarter.ai. The show would not be possible without the talented team at Cosmic Standard, our producers, Samaya Adams and Asia Simpson, our technical director, Jacob Winnick, and our executive producer, Eliza Smith. At Dropbox, special thanks to Benji Baptiste for production assistance and our illustrators, Fanny Lohr and Justin Tran. Our theme song was created by Doug Stewart, and I'm your host, Matthew Braga. Thanks for listening.